think last class we were able to do closure and commutative property and commutative property.
And unfortunately, on that day,
Yeah.
I did not have light on my phone. So when they are solving closure,
Okay.
when they are by then my phone is so down that so that's why that's the reason I ended it.
Okay. So what I will do for you as a means of recall is that I will start all the properties all over. The basic thing about binary operation is you know how to do your calculation. Okay, you get.
Okay.
Yeah. You should know how to do your calculations. So if you know how to do your calculation, you won't have problem. Let me just quickly give you one question. So if we're on binary operation, but I just want to give this question.
Okay.
If A are B, if I'm writing, can you see my screen?
Yes.
Okay. AB over A plus B, all right? And
Yeah.
3 star B is equal to 2 number 1 over 10. All right. Find the value of B. This is not the usual binary operation you know. Normally, what you are supposed to do is to input the value, but they've deliberately removed one value and they want you to look for that value. All right. So this is at the level the exam will be asking questions. So based on that premise, what we are going to do is just to get to work. It means our A is 3 and our B is unknown. So I can do 3 times B all over 3 plus B is equal to this fraction. I can express it as this is mixed numbers. I can express it as improper fraction. This will be 21 over 10. So from what you have here, we can proceed to say 3B over 3 plus B is equal to 21 over 10. Then we can cross multiply from here. When you cross multiply, you are going to have 10 times 3 will give you 30. So it will be 30B. And that will be equal to 21 into bracket 3 plus B. So this will now give you 30B. And that will be equal to 21 times 3 will give you 63 plus 21B. So we can collect like terms. These are like terms, 30B and 21B. So 21B can come to the other side. I'm just teaching you like I'm teaching a DSS student. Normally at the level of JAM, of this, there's a way I comprise because, you know, your exam is time limited. So we have to make sure that most of our calculation, you are fast on them. But at the level where I need to teach you the basic things, I need to take it slow. So when you are now taking real tests, you need to take questions, practice questions on your own, make sure you are fast. So let me just not show those details. By the time 21B cross to the other side, 21B will carry negative. So you have 30B minus 21B will give you 9B. 9B will be equal to 63. Then you can divide both sides by 9. So this cancel this. And 9 here is 1, 9 here is 7. That means B is equal to 7. So that's the answer. You can keep that. Then I will now go back to the properties properly. Can I go on?
Yes.
Okay. You can want to try with this on your own. If A star B is given as AB plus A plus B, and let's say 3 star 3 star B is equal to, I just want to give you something similar to what I've just done. Let's say we have that is equal to 23. Find B. You can try this on your own and give me an answer. Is there anyone who wants to try that and quickly supply answer to me? Let me just hold on and see someone who can quickly find an answer. I think I have how many people here? Wow, more students are coming in. Fine. So let me see who will be the first to give me an answer. Or should I supply a list of answers? Yes, anybody can talk?
Ten, sir.
Yeah, what's the answer?
10.
10.
Yes.
10 is not correct.
5.
Who said 5? Blessing.
Me.
Oh, Suliat.
Sir.
That's correct. 5 is correct. 10 is not correct. 5 is correct. Okay. Is there anyone who can talk us through the solution? Probably you can explain how you got your answer, Suliat.
Actually, sir, you said we are going to use the formula AB plus A plus B. And
That's correct.
we
You have
have
to refer to this formula if you must solve it. Yes, you are correct.
A as 3, and we don't have the B because you're actually looking for it. So we actually use 3 times B plus 3 plus, like we have to use that 3 times B, we have to put it in brackets, plus open bracket 3 plus B close bracket equals 23.
Okay.
So the 3 times B will be 3B plus 3 plus B.
Okay.
Then we collect like times, we have to put the 3b plus b, and we have to take the other 3 going to the 23. That would be 23 minus 3. That would
Yeah.
be 4b. So 4b equals 20. That's 23 minus 3 is 20. So we have to divide both sides by 4. That would be 5.
That's correct. Very correct. Anywhere you see A in that formula, you put 3 and B retain its original value. Yeah, fine. I love that. Let me twist it a bit. I have something interesting to show you. Based on this same formula, okay, I want you to work out. I'm not going to change this formula. So someone should be able to work out this for me. If you have A, okay, let me change the color. Let me change the color now. A star minus 5 now is equal to, what should I give you now? Let me see. Okay, minus 17. What do you think A will be? Find A. Using this same formula, A star, not times, so it's a star. And because I'm using star, it can be any other non-unique sign or symbol. So I want you to get used to that. It can be any other non-unique symbol. A star minus 5 is equal to minus 17. Let me see if I'm not making a mistake yet. I'm not. Go ahead. It will work. Because I want everybody to get it, is why I'm trying to give you another option. So you can play around numbers. That's one funny thing about mathematics, which makes mathematics very interesting. The same question, just be changing numbers. You can think of what you can do together. Just decide to take one away, you know, a very interesting solution will come out. And I'm deliberately setting this because in binary operation, order is very important. Don't go and put A where B is supposed to be. You are not likely to get the correct answer if you misplace those values.
Sir,
Yes.
the answer is 3.
Yeah, 3 is correct. Very correct. Thank you for that. And I want to believe others are also getting it. Please, if you don't get it, stop. Because we are not just here to show someone who knows more. Yes, Afiz.
Please, I don't get it. Please.
Okay. Did you get the first one?
Yes.
Okay, you got the first one. Good. If you got the first one, then you are not far away from the explanation. You will get the second one. Is there any other person who doesn't get that so that I can quickly know who and who to explain to? Lizzie is on this call, but she's not talking.
I don't. I joined the class not long ago. Sorry.
Oh, okay. All right. But are you flowing with us? Let me know.
Yes, sir.
Oh, that's great. So let's start the explanation. All right. So I'm still like we are going to arrange A and minus 5. We are going to arrange them in order of A and B. So what I have is when you have two letters written as AB, it means you are multiplying A and B. That's the rule in mathematics. So now here, my A is my A, and then minus 5 will now replace B. So I'll have A times minus 5. All right, that is my AB plus A still retain its original value, then plus B. Now I know what my B is, minus 5. all right? And that should give me minus 17. So a times minus 5 will just be minus 5a, and then plus a again, and then minus 5, because plus times minus will give you minus, and then your answer should be minus 17. Now, minus 5a plus a, this is where you are likely to have issue because you need to collect like terms. When you are owing someone 5 eggs and all you have is just 1, so if that person should take the only one you are still owing 4. So minus 5a plus a will give you minus 4a. And I can tell you one of the trick JAMB is playing on students is this issue of sign. Even most times when I do some maths, I make some simple mistake, just misplacing some order or sign, or it happens to anybody, all right? But it is only when you practice much enough that you limit those errors. You have to practice as many questions as possible. That is when you limit those errors, all right? And for some of us, I like doing most of my calculation offhand. I may not want to write everything down. I'll just process it on my head. All these questions I'm giving you, no, I didn't write it anyway. So I like processing a lot of things on my head, you know. So that's me anyway. So let's move away from there. So we've processed minus 5a plus a, then minus 5 is equal to minus 17. So all we need to do is transfer this minus 5 to the other side. So minus 4a will now be equal to minus 17 plus 5. This minus 5, once it crosses to this other, it will become plus. So like we did on this other side for a, minus 17 plus 5 will give you minus 12. So minus 4a is equal to minus 12. So you just divide both sides by minus 4, minus 4. And then this cancel this. Minus will also cancel minus. So your a is equal to 3. To know whether you are correct, anywhere you see a in this formula, put 3 and then minus 5 and work it out. You will see that you should be able to get the correct value they give you, this minus 17. Put 3 here, okay, and then your minus 5 is already here. So when you arrange it according to this formula, you will get this minus 17. That's how you know you are correct. That's how you know you are correct. So our answer is a is equal to 3. Any question before I move further? Any question before I move further? Okay. Hafiz, are we together now?
Yes.
All right, nice one. So I want to go back to where I stopped last week before I now move further from there. I want to go to the properties, and I listed all the properties of binary operation. So I started last week with closure properties, and I'm still going to go back to that for the sake of those who missed out on that class. I would have said, please go and watch last week. I don't know. I think the organizers are hosting the video on some platform, possibly YouTube. I don't know. But then if you have access to it, it's being recorded. So you can go and check how we ended up last week. But I will still decide to pick it up from there. I may not want to dwell on it so much. So the closure property of a binary operation stipulates that when you operate on a particular set of number, then your answer should also be in that set of number. When you operate on a particular set of number, all right? And I'm going to demonstrate something for you. This is not the usual, this is not the usual, I don't know, maybe I should complicate it that way. Okay, so I want to operate on set of even numbers, okay? And of course, I'm going to be using multiplication binary operation multiplication. So if I have 2, 4, and I have 6, and I have 8, and I have here 2, I have 4, I have 6, and I have 8. Okay, let me just stop at this. Okay, this is a binary operation on its own. It doesn't matter. It's in form of A and B. So the multiplication we are talking about is probably I can just say multiplication maybe in modulo. Should I use mode? What should I use now? I don't want to use modulo. Let me not complicate it so that because most of you are not exposed to modular arithmetic. Let me just leave it as normal multiplication. Now, so this is a set of given numbers. Can we check whether all our answers that we are going to get is going to be even numbers? When you multiply 2 by 2, what will you get? You get 4. If you multiply 2 by 4, you should get 8. 2 times 6 will give you 12. And 2 times 8 will give you 16. All right? Yeah, thank you. 4 times 2 is 8. 4 times 4 is 16. 4 times 6, 24. And 4 times 8 is 32. 6 times 2 is 12. 6 times 4 is 24. 6 times 6 is 36. 6 times 8 is 48. 2 times 8 is 16. 2 times 4, 8 times 4 is 32. I deliberately want to introduce this concept of table under it because when we get to identity and inverse, we are likely to deal more with tabular binary operation than the regular ones. 8 times 6 is 48, of course, and then 8 times 8 is 64. You can see that all the number we have in this box, they are all even numbers. So I can say that for any table, no matter how much you extend the table, either further to the right or further down, any addition you do with any set of even number, when you multiply two even number, you can never get anything outside even number. So what I will say is that this binary operation that I've used is closed. It's closed because anytime I make use of even number, and I operate this binary operation, my answer will also be an even number. That's what they call closure. All right. And even for odd numbers, if you operate two odd numbers on themselves, you should get odd number too. All right, you get odd number. Well, but yeah, you get odd number. 3 times 1, 3 times 3, 3 times 5, 3 times 7, everything will be odd. So you can see it depends on the set of number you are using. That will always give you that. And there are some binary operations that are not closed. So in this case now, it is closed. In some other place, it may not be closed. Let me give you an example. I'm going back to the first example I gave you. If you have written it down, or if you have not, I will just show it here. I gave you this example. A star B is equal to AB divided by A plus B. The two numbers that I use are whole numbers. And what are they? 3 and 7. 3 and 7. If you put 3 and 7 in the position of A and B, 3 times 7 will give you 21. 3 plus 7 will give you 10. But 21 over 10 is not a whole number. It's a fraction. So if you are operating it and you want it to be closed, then this operation is not closed. That's how we say it, that this binary operation star is not closed because the binary operation has the way it is defined. All right. So any binary operation of this one, it is not every division that is not closed. So this particular one we just used is not a closed binary operation. So we say that the property of closure is not satisfied. So assuming they said just make use of any whole number and operate this binary operation. Some of the answer will be correct. I can tell you some of the answer will be correct. All right. Some of the answer will not be correct. In fact, there are some answers that will not be defined. Because if you are using whole numbers, 0 is part of them, or especially if it is integers. All right. 0 times 0 times what do you call it? 5 will be 0. So you get a 0, and anything over 0 is 0. So you have that. But when it is, let's say, we want to use 1 and 3. Okay, 1 times 3 is 3. 1 plus 3 is 4. That's 3 over 4. 3 over 4 is a fraction, not a whole number. So it's not closed. If you use 3 and 3 now, 3 times 3 is 9. 3 plus 3 is 6. Do you see that? So 9 over 6 is not closed because you are going to have 3 over 2. That's a fraction. One whole number, 1 over 2. So a lot of it will not be closed. All right? A lot of it will not be closed. We can have the one that will give you a whole number. Let me give you an example. If you use 10 times 10, you get 100. Let's say we have 10 and 10. If you use 10 times 10, you get 100. 10 plus 10 is 20. 100 over 20 will give you 5. That's a whole number. But it's not all the numbers that will occur in that way. So most times you get fraction more than you get whole numbers. All right. The same thing as a lot of just numbers, a lot of social that you get. All right. So you have that. Okay. All right. So that's the property of closure. Do you all understand that before I move further?
Yes.
Okay. So I think I've explained that closure, and I will implore you, please, maybe next class, go and search for questions. I've told you, solve questions. If you can't solve questions, bring questions to class so that it won't be like I'm the one thinking of question for you. I want you to bring questions to class. You
Hello,
have
sir.
past question in jam. Yes.
You have like 8 minutes more.
8 minutes. Okay. All right. Thank you. So, since we all understand the property of closure, I think we should quickly analyze that of commutativity. Let's go for property of commutativity, that is commutative property. So I've explained closure, and I've already explained where it will not be closed. For commutative property, so I'm going to time myself. In the next 5 minutes, I should be through here so that commutative. So for commutative, or what we call commutativity, the only thing you will need to know is any binary operation. I told you binary operation is not unique, so don't get stuck with star. Don't get stuck with star. I can change the operation. It means the same thing. This is the condition for commutativity. It is not in all cases that when you interchange the operations or the values or the variables, you get the same thing. But anytime you interchange and you are able to get the same thing, then you will say that it is commutative. If at any time you interchange, you get the same thing, you will say that it is commutative. Again, I want to go back to the first slide I showed you, this slide. If I decide to put 7 first and put 3 next, this operation will be commutative. It is not closed under the operation, under the set of whole numbers, but it is commutative. Because now my A is representing 3, my B is that addressing me? I'm not sure.
Collect matches from Brachiso.
Okay.
Fabian
Chinaza,
please
can
mute
you mute your
yourself.
mic? Thank you. Okay, so I'm saying that when you have 3 here as A, 7 as B, 3 times 7 is 21. 3 plus 7 is 10. You still get 2 whole number 1 over 10. But if you decide to change it, you put 7 as A, you put 3 as B. 7 times 3 will still give you 21, and 7 plus 3 will still give you 10. So you still get the same result when you interchange, and that is what this is addressing, this condition of commutative property. It's saying that when you interchange your values, you will always get the same answer. But when you get such answer, then you can conclude that this is a commutative property. And is also going to work for this table we have on this page. 4 times 4 is the same thing as 4 times 4. 2 times 6 is the same thing as 6 times 2. So this tabular operation we have here is commutative. But I'm going to show you an example that is not commutative, and that will be our last class for today. So if you have, the last question I'm going to supply you anyway. If you have something like A star B, or maybe I should just still change, I should just still flex my muscle a bit. X star Y is equal to 2x minus y, all right, plus y squared, all right? And I'm looking for 1 star 2. When you do this, so you know that your x is 1, your y is 2. So 2x, that will be 2 minus 2 plus y squared. 2 squared is 4. 2 minus 2 will go. So my answer is equal to 4. But if I decide to do 2 star 1, the same equation, no, I just change the numbers. What am I going to get? That will be 2 times 2, that will be 4. Minus y, my y is 1, minus 1, plus my y square will now become 1 square, which is minus 1. So here, I'm getting 4 minus 1 plus 1. I still get 4. Now, let's use another number. This same thing, 2x minus y plus y squared. All right? Let's use 3 and 5. 3 and 5. New one. So I have 3 star 5. So I'm expecting to have 2 into 3 minus 5 plus 5 squared. All right? My time is almost off. So this will now give me 6 minus 5 plus 25. Plus is here. And that will give you 6 minus 5 is 1. 1 plus 25 is 26. Now let us interchange. 5 star 3. That will give me 2 into 5 minus 3 plus 3 square. 3 square. So what I now have is 10 minus 3 plus 9. And that is 10. 10 minus 3 is 7. 7 plus 9 is 16. So you can see now that for this, it is not commutative. So we say star is not commutative. That's the binary operation, not commutative. All right. So at this junction, when you interchange and you don't get, the same answer, the first one, 3 times 5 will get 26, but 5 times 3 will get 16. So it is not commutative. I think 1 and 2 in that regard was just a coincidence, but it will not work for all the numbers. That one I know. It will not work for all the numbers. But for other, it will work for all the numbers. So these are the situations we need to work on, I will get. So tonight now, I've been able to deliberate more on closure and commutativity. We still have other properties to deal with. Hoping that by next week, we'll go ahead and do associative, distributive, identity, and inverse. 4 more properties to deal with. And then we are done on binary operations. Thank you very much. If there is any question, let me have it in 2 minutes.
Thank you, sir.
there's any question, let me have it. See here.